Nuclear power remains one of the most misunderstood technologies to have ever been discovered. Considering that nuclear technology has the capability to provide clean, stable electrical energy, or, in the world, it is essential to comprehend how nuclear power genuinely operates. Nuclear mythology is the collection of skewed social perceptions that have formed unifying ideas against nuclear power. There are always downsides to any technology, however, we forget that we might be standing against something we know so little about. Nuclear energy is more economically viable than it may first appear to be. So let's get this straight. When nuclear power is mentioned, I'm not referencing nuclear weapons. Nuclear power technology is not mutually interconnected with weaponry, in the same way that we use chemical engineering to construct products we utilize daily. We can use nuclear engineering to power those constructive processes. Often, we hear statements regarding the danger of nuclear power simply because it utilizes similar physics compared to nuclear weapons. If we should not use nuclear plants because of nuclear weapons, then we shouldn't use any chemical plants because of chemical weapons. But we probably aren't going to stop using chemical facilities anytime soon. Chernobyl, Fukushima, and 3 Mile Island tend to be the primary examples of nuclear incidents to criticize nuclear power technology. I would agree it is fine to criticize nuclear power, but we should look at why these events happened and why the incidents shouldn't stop us from implementing nuclear energy. In 1979, the United States 3 Mile Island nuclear power plant's core began to melt due to a cooling malfunction in the second reactor. The TMI-2 reactor was eventually destroyed. It was stated as the most catastrophic nuclear power plant incident in American history. Although, after a couple days after the incident, insufficient radioactive gas was released to cause any dose above background levels to local residents, there were no injuries or adverse health effects from the 3 Mile Island incident. In 1986, Ukraine experienced a nuclear accident at Chernobyl. The Chernobyl accident was the result of a flawed reactor design that was operated with inadequately trained personnel. During the night of the incident, 2 Chernobyl plant workers died due to the explosion. The resulting steam explosion and fires released at least 5% of the radioactive reactor core into the environment. Many parts of Europe were disposited with the radioactive materials. A further 28 people died within a few weeks as a result of acute radiation syndrome. However, the United Nations Scientific Committee on the Effects of Atomic Radiation made a statement. There was no evidence of a major public health impact attributable to radiation exposure 20 years after the accident, apart from some 5,000 thyroid cancers resulting in 15 fatalities. In 2011, Japan experienced a major earthquake. The Great East Japan earthquake of magnitude 9.0 provoked a 15-meter tsunami, disabling the power supply and cooling of 3 Fukushima reactors, causing a nuclear accident. All 3 cores largely melted within the first 3 days due to high radioactive releases over days 4 to 6. The accident was rated a level 7 on the International Nuclear and Radiological Event Scale. There have been no deaths or causes of radiation sickness from the nuclear accident, but over 100,000 people were evacuated from their homes as a preventative measure. Official figures do show there have been 2,313 disaster-related deaths among evacuees from Fukushima. Okay, so the United States 3 Mile Island accident was not much of a statistical catastrophe. It was an unfortunate lesson in the way nuclear power plants were constructed and designed. The federal and state governments additionally had to learn how to manage potential casualties, injuries, environmental damage, and cleanup. Ukraine's 1989 Chernobyl incident was much more significant, propelling the global nuclear safety regime. To help address risks, the U.S. and other countries and international organizations provided assistance, such as equipment, training for nuclear reactor operators and regulators to improve the safety of these reactors and make sure people were prepared if something went awry. The International Atomic Energy Agency convened a conference that led to the adoption of the Convention on Nuclear Safety. This treaty developed in the aftermath of the Chernobyl accident to promote the safety of nuclear power reactors around the world. In 2010, countries mentioned to the U.S. Government Accountability Office that the convention did indeed contribute to global nuclear safety. Japan's nuclear Fukushima incident additionally had global influence, prompting a reckoning among nuclear safety regulators. They formed standard operating conditions, such as requiring backup electric generators in case a site lost power and planning for previously unimagined accident scenarios. No industry is immune from accidents, and industries must learn from them. In every scenario, the nuclear power industry considered each event seriously. Federal governments and global agencies are pressured internally and publicly to implement intense safety regulations, advanced designs, and consult nuclear organizations. Unsurprisingly, these methods did create nuclear power plants with extremely effective security measures, especially when compared to alternate energy sources. Regulations for nuclear power plants obviously vary, sustaining rules which may include licensing approvals. One approval requires that the effects of new plant's potential core melt accident must be confined to the plant itself, without the need to evacuate nearby residents. And although these regulations are nice, are they supported by technological security? There has been the prominent assumption that the nuclear power plant's accidents are low probability but extremely consequential. We find that with each generation of nuclear plants, the frequency for a large release of radioactivity from severe accident decreases. Generation 3 reactors release a factor of 1,600 less radioactivity than Generation 1. Approximately 80% of nuclear energy accidents originate from human error. Policies and organizational infrastructure help to subdue this, except the 20% of equipment failure is seriously considered. The newest generation of advanced reactors, the AP1000, utilizes passive safety mechanisms. Passive safety refers to the ability of advanced reactors to shut down and remove excess heat without human intervention. In the unlikely event that a nuclear power plant loses power, passive safety protocols use uninterrupted physical systems to keep reactors safe and cool the core. Gravity and the natural circulation of special coolants move heat away from the reactor core without depending upon external power sources, pumps, or human operators. So yes, nuclear power plants are safe, but that doesn't necessarily make them economically viable. Why nuclear power plants are economically viable is correlated with reasons that are less of an engineering problem, more of a political complication. Nuclear power plants produce more energy with the same cost of fuel than any other energy alternative. With just 100 grams of uranium, you can produce 11 megawatts of electricity per hour. Coal plants require 1.5 tons of fuel, and oil-fired steam generating plants need 7.4 barrels to produce the same amount of energy. Operating costs for producing electricity with nuclear power plants are relatively inexpensive. What makes nuclear power plants so expensive are the upfront costs. Nuclear power plants are technically complex and must satisfy strict licensing and design requirements. The design and construction of a new nuclear power plant requires many highly qualified specialists. This process often takes many years with compounding financial costs. Frequently, design changes and lawsuits arise during construction, causing lengthy delays that further increase the financing charges. In many cases, the charges exceed the cost of building the plant itself. Does this mean nuclear power plants are not economically preferable? No, they still are. Nuclear agencies have written overzealous policies that make nuclear plants unable to do their job. Nuclear energy sources should be monitored and managed in regards to a majority of the current regulations. However, an abundant quantity of unnecessary regulations happen to impede on the functions of other safety policies. Evaluating our regulations would be beneficial. Besides, other energy sources are much more destructive towards workers, environments, and customers' pockets, yet they are not as regulated as nuclear plants are. Nuclear energy is an incredibly underutilized resource that has the potential to solve most of our electrical production problems. It just so happens there are other organizations and movements dedicated to enhancing their profits at the expense of the average human's quality of life. Nuclear power plants are indeed economically viable. We just have to finish building them.